All right, so this video covers the second part of section 4.2 dealing with experiments. Okay, so first thing we're going to talk about is kind of like what we want to try to avoid with experiments. So the example that they talk about in the textbook is an online SAT course. And so you have volunteers for the study. Or experimental units, and you give them some treatment. So maybe some tutoring in SAT, and then you measure to see whether the response, whether there's a response. In other words, in this case, did they improve in their SAT scores? But the problem with this, missing from this experimental design, is that there's no sort of comparison. You want to compare the treatment among several different treatments among different groups in the experimental units. So, for example, their SAT scores improved. Well, was it the tutoring or the test prep that they received? Or was it just they've already taken the test once, and so did they improve just because they've had some experience taking it? So what we want to do is introduce some sort of control. And so this will allow us to control for confounding variables. So did the response that we measured, right, so the outcome, let's say there was an increase, was that caused by the treatment that we imposed on this group? And that is much more easily shown if we have another group to compare them to that did not get the treatment. Okay, and so this is going to allow us to eliminate any confounding variables. All right, so we want to be able to use a comparative experiment. This means some people get one treatment, some people get another treatment. All right, so two or more treatments typically, and we want the two groups to be as similar as possible. And so we get this, the two treatment groups, one getting one of two different treatments. We want those groups to be the same as much as possible, so that the only thing different in the two groups is the different treatments. And so that way, if there's a difference in the response with these two groups, we can say that it was caused by the imposition of this treatment versus in the other group that didn't get the treatment. And the way we make these two groups as similar as possible is through random assignment. So we say we get 1,000 people that volunteer. Okay, we didn't randomly pick the people for the experiment like you would for a survey or a study. You randomly pick people. Here, for experiments, you get volunteers. And where the randomization comes in is that you randomly break them into, say, two groups, maybe three groups, depending on how many different treatments you want to test. All right, so it's the random assignment to treatment groups from all of the experimental units that are now going to make these two treatment groups identical or as close as possible. All right, so the random assignment has to occur by chance. Some sort of chance process. You use a random digit table, you flip a coin, you do some kind of chance process. All right, so let's look at this example and think about what's wrong with this experiment that was run. Okay, so a State Department of Labor noticed that last year, 68% of people who filed claims for unemployment insurance found a new job within 15 weeks. Okay, so what is unemployment insurance? You may not be aware of this. So if you are gainfully employed and you are laid off, then you part of your paycheck and part of your employer every paycheck pays to the state, and they develop this fund and they use that money to pay you unemployment insurance. So for example, I lose my job, I'm laid off, I get some kind of paycheck. It's usually much less than what you actually got. Years ago, I worked as an engineer for McDonnell Douglas, defense contractor. And the Cold War was thawing, and so they were laying a lot of people off. I lost my job as an engineer. And so I had to show that I was looking for work, but then every week I got a check, probably a fourth or a fifth of what my real paycheck was, but it's enough to kind of get you by. I happened to be living with my parents at the time still. It was right out of college, so I was fine. But that's what unemployment insurance is. Okay, so they want to encourage you to get a job as soon as possible so they can stop giving you a check. Okay, so again, let's look at this question. It says that they noticed that last year, 68% of the people who filed a claim for unemployment insurance found a job within 15 weeks. So, they got a check from the unemployment insurance for 15 weeks, and then they found a job, for example. All right, so as an experiment this year, the Department of Labor offers a bonus of $500 to people who are filing for unemployment claims if they find a job within 15 weeks. And then, as it turns out this year, that percent goes up, right? So that percent, the percent who actually do find a job, is 77%. So the percent of people who found a job within 15 weeks is higher than it was last year when they weren't giving a bonus. Okay. So the question is, what's wrong with this, right? And so we're not doing a side-by-side comparison. So, half of the experiment was, essentially last year when there was a control group was last year's group, and then the treatment group, this bonus of $500 if they find a job, was this year's, and so they weren't happening at the same time. All right, so it's impossible to determine whether it was the $500 that was causing people to go get a job more quickly, or maybe it's the economy is better this year than last year, right? So we would have to do like a side-by-side comparison. So what we would have to do is for the people this year, half of the people would get offered a $500 bonus, and the other half would not be told about this bonus. And then we would be able to see a side-by-side at the same year comparison. Did the people who were offered a $500 bonus to find a job quicker, did they actually find? So is there a difference in the percent of people who found a job within 15 weeks in the group that was offered the bonus, the treatment group, versus the control group, which is the group that were not offered a bonus? Okay. Okay, so some basic principles that we need to consider when we're designing an experiment. So comparison, we want to have different treatment groups. If we just have one treatment group, then we can't really eliminate other confounding effects that might be explaining the response that we measure at the end of our experiment. So we want two groups. We want two identical groups. And so the only way we can get these identical groups is by using random assignment, right? So we're going to randomly assign our volunteers to two groups. If the groups are big enough, we're going to assume that those groups are the same. The only difference in the groups is going to be one's getting one treatment, one's getting either no treatment or some other treatment. So random assignment is important there. And then that's what allows us to control for all other variables, right? So the two groups, because they were randomly assigned, the groups are big enough, we can, any differences are going to sort of average out. And so now the two groups are the same. Everything about the groups are the same. The only difference is the treatment. And so any effect, a difference in the responses in the two groups can be sort of blamed on the treatments. All right. And so then we talked about big groups. We want groups big enough. And that deals with replication. So the replication stands for how many people are in each treatment group. We don't want 2 people in one group, 2 people in another, because those people may be very different. But if I have 2,000 people in one group and 2,000 people in another group that were randomly assigned to those groups, then we are pretty safe to assume that those two groups are very similar. And so any difference in the response measured at the end of the experiment can be related back to the actual difference in treatments. All right, so one sort of the simple design name that we use here is called a completely randomized design. And so what we do with that is we take the experimental units, we randomly assign them into 2 treatment groups, maybe 3 treatment groups, maybe 6 treatment groups, just depends on what we're trying to test. But break them up into at least 2 groups, and then each group gets a different treatment. Now, one of those treatments could be a control, so that would be the control group. Typically, a control group gets either no treatment or get a treatment that is traditional, right? So if you're talking about someone who's got high blood pressure, we wouldn't give, and we'll talk about this term later, placebo, we wouldn't give them a fake treatment because then the people might die, right? So we want to give them the traditional treatment, and then we think we have this new treatment that's going to improve over the past treatment. So we have a new improved treatment for blood pressure, high blood pressure, and then we give the traditional one. So a control might be the old standard treatment, or it might be no treatment. It all depends on the ethics of the situation. And then at the end of that, we just compare the results, right? Is there a difference in the results for the 2 treatment groups? And if there is, then we can be pretty safe to assume that the difference in the responses were caused by the difference in the treatments. All right, so here's another, an example of a completely randomized experimental design. So officials at the Philadelphia Veterans Affairs Medical Center recruited 132 obese adults. So 1/3 of the subjects were randomly assigned to a low carbohydrate diet, 1/3 were randomly assigned to a low fat diet, and then the last third were not assigned to any particular diet. And so let's look at creating the diagram for the completely randomized experimental design. So again, we first start with all of the, in this case, subjects, experimental units. They're humans, so we call them subjects. 132 obese veterans, or I guess could be family members of, because if you're a family member of a veteran, you can go to the medical center. But anyway, so 132 obese people, and we are going to randomly assign them, this time into 3 treatment groups. The first group is going to have a low carbohydrate diet. The second group gets a low fat diet, and the third group gets no particular diet. They just are the control. And then we compare, after a month of being on these diets, or maybe 6 months, or maybe 2 years, whatever, some time frame, we would compare weight loss, maybe, or body fat content, or we would have to figure out exactly what we're going to measure. Okay, the AP test. So and this is the same thing in my class as well. If you're asked to design a randomized experiment, it's not enough to draw this diagram, right? You have to explain how you would break the 132 people up randomly. So go through maybe a random digit table. So here's an example of what, like a write-up, you would need another paragraph here. So you would start by numbering the population, which is the 132 people. We got to use 3 digits because 132, that's 3 digits. That number is 3 digits. So we do 001 through 132. We number everybody, and we start on a particular row of the random digit table. We look at 3 digits at a time, and we would select 88, which is really, we would think about, maybe it would be better to say we're going to select 44 numbers. We ignore any numbers above 132. We ignore 000 and any repeats. And then the adults that correspond to those 44 will be the people assigned to treatment group number 1, low carbohydrate diet. The next 44, that's why I selected 88, right? So I selected 44 and then another 44. So the first 44 are in treatment group 1. The second 44 people selected, the numbers selected would correspond to those people who will be in treatment group 2. We don't randomly select the last group just by default. Those last 44 people that were not selected, those people will be in the third group or the control group. All right. So not only should we say kind of how we're going to do this, how we're going to assign the people to the three groups, we also want to talk about what we're going to measure. And so we might look at body fat content, or we might look at just overall body weight. You know, depends. We just have to come up with something that we're going to measure. So measure and compare the average decrease in body fat in the three groups, for example. And then we'll see, did one group lose more body fat than another? You know, we randomly assign them to groups. So the three groups are identical. And so any changes in body fat, any decrease in body fat can be assumed that it is caused by the different treatment groups. Okay, so here is your homework for the second part of section 4.2.